In this video, we will be solving some numericals from concentric shells. So before starting with these numericals, you must have watched the earlier video in which the potential on concentric shells is discussed. So our first question is, here we are given two concentric shells of radius r and 2r. That means the radii of inner is r and of outer shell is 2r. So this is given. Another thing given is the charges. The charge on inner shell is q and the charge on outer shell is 2q. So here we have minus 2q charge and the charge on inner shell is q. So now we will be using our knowledge of potentials to calculate the potential difference between these two spheres if the inner sphere, which is earlier carrying charge q, its charge is doubled. Then what will be the potential difference between these two spheres? So we will be calculating that. So for this, we first have to find the potentials initially on both of these spheres. So I will be naming the inner sphere as sphere 1 and outer sphere I will be calling it sphere 2. So firstly I will be calculating the potential on inner sphere. So what will be the potential on inner sphere? It will be potential due to itself plus potential due to the bigger sphere, the outer sphere. So firstly, potential due to itself. Potential due to itself will be equals to K, charge on itself, charge on it is Q, that is given, divided by its radius. Its radius is R, plus potential due to the outer sphere. Now we know due to the outer sphere, this inner sphere will be anterior part, and in the interior of a shell potential remains same. So for the outer sphere the potential will be K charge on that sphere divided by its radius. Radius of outer sphere is 2r. So this 2 and 2 will get cancelled out. So our entire equation k q by r plus k minus q by I r will get cancelled. So our potential on inner sphere will be equals to 0 initially. So now we will be calculating the potential on outer sphere. So now outer sphere, it will be again equal to the sum of potential due to itself plus potential due to the inner sphere. So potential due to itself will be equals to K charge on itself divided by its radius plus potential due to inner. Now potential due to inner will be equals to K Q divided by, now we have already studied that the inner charge Q. Now this shell will act as an exterior point for the inner shell. So distance of this exterior point is of course 2r. So this is the value of potential. Now we will be solving this value. We will have 2r minus 2kq plus kq. So this will come equal to minus kq by 2r. So this is potential on outer sphere and potential on inner sphere is 0. So what is the potential difference? Of course potential difference will be equals to, we can write it as final minus initial. Initial is 0. So potential difference initially. So initial potential difference will be equals to same kq by 2r. So now we are doubling the charge on inner sphere. So when we double the charge on inner sphere, we will be calculating the potential on inner sphere firstly. So what will be the potential on inner sphere? So potential on inner sphere will be equals to K charge on inner sphere. Now the charge is doubled. Earlier it was carrying Q charge. Now it will be carrying 2Q charge. This is given in the question. So we are doubling the charge on inner sphere. Divided by radius is r plus potential due to outer sphere. The charge on outer sphere is constant, minus 2q. So potential due to the outer sphere will be equals to k minus 2q over the radius of outer sphere is 2r, that is given in the question, divide by 2r. So this 2 and 2 will get cancelled. So our potential will come out to be K2Q minus KQ. So that can be written equal to KQ by R. So this is the potential on first sphere, the inner sphere. Now we will be calculating the potential on outer sphere. So this will be equal to potential due to that sphere itself plus potential due to the inner sphere. Now inner sphere carries double charge, divide by 2r. Now this entire value will get cancelled. Potential on the outer sphere is equal to 0. So what is the potential difference? We can write the same final minus initial. So if you do final minus initial, you will get 0 minus KQ by R. So that is basically KQ by R. Even if you are taking negative, that is okay. The negative and negative will get cancelled out. Now, earlier potential difference was equal to KQ by 2R. Now the potential difference is KQ by R. So what is the change? Earlier it was, I will be writing it over here. So earlier potential difference I will be writing it potential difference initial, it was equal to KQ by 2R, and now potential difference has become KQ by R. So what is the change? New potential difference is doubled the value of initial potential difference. So this was our question. We were asked that what is the change if the charge on the inner sphere is doubled, the potential difference between the two spheres will. So our answer will be become 2 times. Why? Because earlier the value was KQ by 2R, now the value is KQ by R. You can easily take its ratio and get the answer. So our correct option is option E. So that is our first numerical. Now we will be moving on to second numerical. So here in the second question, we are given 3 concentric shells A, B and C, and we are to calculate the ratio of charges on inner and outer surfaces of outer shell, that is shell C. So to proceed with, we will be drawing a diagram. So like this, we have 3 concentric shells, and the inner shell, it carries charge Q. So it is carrying charge Q over here. Now due to this charge Q, this is positive charge, a minus Q charge will be induced on inner surface of shell B. Now shell B already contains charge 2Q, and this minus Q which is induced on the inner surface of shell B, due to this a positive charge, opposite charge will be further induced on outer surface of shell B. So a plus Q charge will also get induced on shell B. Now the total charge on outer surface of shell B, so I will be writing it as charge on shell B on outer surface. This will become equal to 2Q plus Q is equal to 3Q. So now the outer surface of spherical shell B will carry 3Q charge. Now this 3Q charge is of course positive, and due to this charge a minus 3Q charge will get induced on the inner surface of shell C. And shell C already contains minus Q charge. Now due to this minus 3Q charge induced on inner surface of shell C, a charge plus 3Q will get induced on outer surface of shell C. So now the total charge on outer surface of shell C, I will be writing it as C out, will become equal to plus 3Q minus Q, that will become equal to 2Q. So now the outer surface of shell C carries charge of 2Q and inner surface of shell C carries minus 3Q charge. So we have to calculate the ratio of inner and outer surface. So ratio of inner and outer surface will be equals to inner over outer. Inner the value is minus 3Q, outer the value is 2Q. This Q and Q will get cancelled and we will be left with minus 3 by 2. So this is your correct option and this is option number D. In third question, we are given a uniformly charged hollow sphere of radius capital R and its potential on its center is given V. So we are given potential at center is V. Then electric field at distance small r from center of sphere, that is what we need to calculate. So we need to calculate electric field at distance r from this hollow sphere. See, we know in case of a hollow concentric shell, the potential at center is equal to potential at surface. So we know the potential at surface is equal to potential at center, because inside the spherical shell potential remains constant and the value is equal to potential on the surface. So we know about this value, and this potential is equal to KQ divided by, we are calculating potential at surface and the distance is of course equal to radius capital R. So this is the potential on the surface. Now we have to calculate the electric field. The formula for electric field is equal to KQ divided by square of distance. So distance over here is small r, so its square will be equals to small r square. Now from the above equation we can say that KQ is equal to V into R. This R will get multiplied over here, so we will be getting KQ is equal to VR. So we can replace this value of KQ by VR. So what we will be left with, VR over R square. So electric field is equal to VR by R square. Now this is your option A. So correct option is A. A is your correct option. In this question, we are given two concentric spherical shells carrying charges plus Q and minus Q. We have to choose the correct options. We might have number of correct options. So we can read these options and check whether they are correct or not. See, our first option is at A, electric field is 0, but electric potential is non-zero. So now point A is inside the first spherical shell, and we know inside a spherical shell which is carrying some charge on its surface, electric field is equal to 0, Faraday cage. So a hollow conductor will not have any electric field inside it. So our first part of the question, at point A electric field is 0, is correct. Second part, but electric potential is non-zero. So we have to check what is the electric potential inside at point A. Now we know electric potential inside the shell is equal to electric potential on its surface. So we have to calculate what is the electric potential on surface of this shell. So what will be the electric potential? Its electric potential will be equals to electric potential due to itself plus electric potential due to the outer sphere. So what will be the electric potential on the surface of first shell? So I'm writing it as surface of first shell, electric potential at surface of first shell. This will be equal to electric potential due to itself, it is carrying plus q charge, let its radius is r1, and plus electric potential due to the second shell which is carrying charge minus q. So electric potential due to that will be equals to plus k, it is carrying charge minus q, divided by its radius, let its radius be r2. Now here, because r1 and r2 are two different values, so this answer can never be 0. So electric field at surface of first spherical shell will be non-zero. So this will be non-zero because r1 and r2 are two different values. So our answer is non-zero. That means there is some electric potential at surface of the first shell. If there is some electric potential at the surface, same electric potential will be at the center of that shell. We know electric potential remain constant. That means second part of the statement, but electric potential is non-zero, is also correct. So our first option is correct. Now we will be moving to the second option. What is given over here? It is asked that at B, electric field and electric potential both are non-zero. Now if we calculate the electric field at point B, what it will be? It will be electric field due to the inner and electric field due to the outer. Now due to inner, same concept will be used as we have used in the first option, that due to the inner surface, when we calculate the electric field, it will have r1 square, and for the outer surface it will have r2 square. Now these two values are different. So even if charges are opposite, minus q and plus q, still the value will be non-zero. Therefore electric field at point B will be non-zero. So first part is correct, electric field is non-zero. Now second part is electric potential is also non-zero. At point B, electric potential is also non-zero. So what will be electric potential at point B? It will be due to first. So first let this distance, let it be capital R, distance of A to B. Then the electric potential due to interior shell will be equals to K, it is carrying plus Q charge, divided by, let this distance be capital R. And electric potential due to the outer, the value will be K, it is carrying minus Q charge, but radius of the outer is different, let it be R dash, so it will be R dash. Now again R and R dash are two different values, that means electric potential will be some non-zero value. So it will also be non-zero, it will also be not equal to 0. So we can say electric potential is also non-zero. So in this way our option 2 is also correct. So we have already seen that option A and B are correct. Now in option C we are given at point C electric field is 0 but electric potential is non-zero. Now one thing we must understand over here, for point C is a exterior point. Now for point C, this total system behave as a single charge. So what is charge over here? Plus Q and minus Q. So what is total charge of this entire system? Plus Q minus Q. Total charge of this entire system will be equals to 0. So for point C, this entire system carries charge C. That means electric field, it also contains charge, will become 0. Similarly, potential that also contains charge will become 0. So but In option C, it is given that at C, electric field is 0, but potential is non-zero. So first part is okay, electric field is 0, but electric potential is non-zero is wrong. So we will say that option C is incorrect. Now next option D, at C, electric field and electric potential both are 0. So this is the correct option, because C is the exterior point. For this, the entire system will behave as a single charge, and the value of this charge is minus Q plus Q equal to 0. So electric field will also be 0, electric potential will also be 0. So in this question we have three correct options: A, B, C is wrong, and D. So these are our three correct options for this question. Here in this question we are given A and B, two concentric spherical shells, and only A is given positive charge and B is connected to earth. Now we have to check the correct option. First option is charge on the outer surface of shell B is 0. Now shell A has positive charge on its outer surface. Therefore, the inner surface of B will carry minus Q charge. I will be drawing this over here. So as plus Q charge is present on the outer surface of shell A, that means minus Q charge will be there on the inner surface of B. Now plus Q charge will be there on the outer surface of B. Now when B is connected to ground, this entire positive Q charge will get neutralized. So this charge will get neutralized. Therefore, there will be no charge on outer surface of shell B. So there will be no charge. So first option is charge on outer surface of B is 0. So answer is correct. Now coming to second statement, the charge on B is equal and opposite to that on A. Now what is the charge on B? There is no charge on the outer surface of B, but there is charge on inner surface of B. What is that charge? Minus Q. So minus Q is charge on inner surface of B. And what is charge on A? Charge on A is plus Q. So we can say the charge on B is equal and opposite to that of A. So even your statement second is also correct. Now coming to third, inside A and outside B is 0. Now field inside A will of course be 0. Here there will be no field. Again same concept, that a hollow conductor act as a Faraday cage. It contains no electric field, so there will be no electric field inside A, and outside B is also 0. Now why field outside B is 0? See, what is the total charge? Plus Q on surface of A minus Q on inner surface of B. So what is the total charge? Total charge is plus Q minus Q. So what is total charge? 0. If total charge of the system is 0, then what will be the electric field outside B? So electric field will also become equal to 0. So that means field inside A and outside B is 0. So all these three options are correct. So we will be taking the fourth one, that is all of above are correct. So here in this last numerical, we are given two concentric shells, first of radius A, second of 2A, and the potential in the inner shell is 10 volts. So here we have potential of 10 volt, and at the outer shell it is 5 volt. And we are asked that what will be the potential at center. See, this is quite easy. Here we are given 10 volt electric potential at the surface of shell A. We know that inside the shell electric potential remains constant and it is equal to electric potential at the surface. So throughout this shell electric potential will remain 10 volt. So at the center also this electric potential will also be 10 volt. So our answer is A.